In our last section, we worked on one-step equations. In section 2.3, we're going to be working on two-step equations. So we're still going to be using the properties of equality for operations, for addition, subtraction, multiplication, and division. We're still going to be multiplying by reciprocals, but we'll be doing multiple things in each problem. Key vocabulary you need from this section are what are like terms, what is an input, and what is an output. Okay, if you take a look at this problem, I want to isolate n. And to do that, the first thing I'm going to do is I'm going to subtract 4 from either side of the equation. So I'll get 2/7 n is equal to 10 minus 4 is 6. And then I would multiply by reciprocal, so I'd multiply both sides by 7/2. This again creates, multiplying by a reciprocal eliminates this item. They simplify out to be 1. 2 goes into 6 and leaves 3. 3 times 7 is 21 is equal to n. If we look at another example like that, when I have like terms are terms that contain the variable to the same power. Okay, so I can combine these two items together. I have negative 7f plus 4f. That's going to become negative 3f. And then if I divide both sides of the equation by negative 3, 6 divided by negative 3 is negative 2. And that will be equal to f. Excuse me, I started to write t. Okay, if we're looking at the input of a function, so normally when we're talking about inputs and outputs, we're thinking about x as an input and y as the output. Okay, I plug values in, I get results back out. The output of a function is 9 less than 10 times the input. Well, 10 times the input would be 10 times x. 9 less than that would be minus x, and that's going to be my output. So I've created an equation that models that, 9 less than 10 times the input. Then I want to find the input when the output is 11. Find the input when the output is 11. So if that's equal to 11, if I add 9 to either side, 20 is equal to 10x. And then I divide by 10, x will be equal to 2. So when my input is 2, my output is 11. If we tested that, I would plug it in. Y is equal to 10 times 2. Excuse me, it wouldn't be y. It would be, is 11 equal to 10 times 2 minus 9? Is 11 equal to 20 minus 9? Yes, 11 is equal to 11. Okay, so I'm able to work through this and then also check my work. If we look at this in a format that looks like a word problem, as a scuba diver descends into deeper water, the pressure of the water increases on the diver's body. The pressure at the surface of the water is 2,117 pounds per square foot. The pressure increases at a rate of 64 pounds per square foot for each foot the diver descends. Find the depth at which a diver experiences a pressure of 8517 pounds per square foot. So let's write a verbal model. And the verbal model basically means that the pressure will equal the original pressure, right, surface pressure, plus this 2,017 pounds per square inch times, so let's just call that the additional pressure, times the feet of descent. Okay, so I apologize for my bad handwriting, but you get the idea. The pressure at any given depth will equal the surface pressure plus the additional pressure times the number of feet of descent. And if I wrote that as an equation, I know that my pressure would be equal to the original pressure, right, which is 2,117, plus the new pressure, 64 pounds per square foot, times the number of feet of depth. So I'm going to call that D. So find the depth at which the pressure is 8517 pounds per square foot. So that's the pressure that goes in place of P. That'll be equal to 64 times D plus 2,117. If I subtract 2,117, I'll get 6,400. So if we bring that over here, 6,400 would be equal to 64 times the depth. So the depth is 100 feet. Okay? And that's working with solving two-step equations.